Okay, hello everyone. In our last class, we have been discussed refraction matrices through convex surface. Here we discussed a refraction matrix for convex surface when mu1 greater than that of the mu2. We found the matrix is 1, 0, minus 1 by r, mu1 by mu2 minus 1, mu1 by mu2. Here, in this case, mu1 less than that of the mu2, but refraction at convex surface. And we found refraction matrix is your 1, 0, 1 by r, mu1 by mu2 minus 1, mu1 by mu2. Through concave surface when mu1 greater than that of the mu2, this is the refraction matrix. And in general, here we can write instead of mu1 by mu2, it can be written as mu I by mu O. I for input, O for output. Considering plane surface, by substituting r equal to radius of curvature r equal to infinite, the refraction matrix will be 1, 0, 0, mu1 by mu2. Instead of mu1 by mu2, we can write mu I by mu O. In detail, we have been discussed in our last class. In this class, we are going to discuss system of matrix. In short, it is represented as SM of an optical system. See, this topic not directly mentioned in our syllabus, but this topic is very much essential to calculate the cardinal planes of optical system, cardinal points and cardinal planes, location of cardinal points and cardinal planes. Okay, so let us start. To evaluate the system of matrix of an optical system, here we consider a optical system. Here you can see in between these two surfaces, surface I and 2I, one optical system is present. This is the optical system. Here you can consider that this is a thick lens or combination of lenses, that may be two thin lenses or thin convex lenses or one convex and another concave lens, whatever. So this is in between these two surfaces I and 2I, we have a optical system. Okay, by considering this figure or this diagram, we have to find out the system of matrix of this whole system. I written here some note for your exam point of view. Here you can see, consider a thick lens or optical system enclosed by two surfaces I and 2I as shown in figure. So in between I and 2I, two surfaces, we considered a optical system or a thick lens. Here this is the thick lens or a optical system, combination of lens or single lens, whatever may be. A ray of light travels from point object a dash. So this is the object, a dash is the object. From this point a light ray travels which is in input plane having refractive index mu1. So this object a1 present in the input plane. So this side is your input plane of this optical system, this side is the output plane of this optical system. So object is present in the optical, sorry, in the input plane. The object is your a dash. Okay, then refracted through a optical system, this ray b ray, which came from coming from the object a dash, refracted through this optical system having the refractive index is your mu2. So this optical system, whatever we are going to take, its refractive index here considered as mu2. Then converged in output plane having the refractive index mu1. Here after refraction through surface I, the ray converged into the output plane having the refractive index mu1. So here input refractive index mu1, output refractive index also mu1, but the optical system whatever we have been taken over here having the refractive index is your mu2. Okay, here it is written, and then convert in output plane having the refractive index mu1 as image d dash. So here image is your object is your a dash, image which is formed in the output plane named as d dash. Okay, yi, this is yi represents input or object information or coordinate of object. YO is the output coordinate or information of image. Okay, from the figure, uh, just we have to investigate the propagation of light. Now from the figure, if we are going to investigate the propagation of light, then what we can get? Step 1, here, ray starts from A and reaches at point B due to translation of ray. Here A dash is your object. A ray starts from A and reaches at the point B. That is your step 1. If I am going to consider step 2, the ray is refracted at point B or on the surface, on the convex surface I. Then after refraction at B, ray travels from B to C. Here B to C, the ray travels in this optical system from B to C, which is so called your translation of ray. Okay, then at C, at this point C, again it will be refracted, which is considered as your step 4, refracted at C. Then in step 5, after refraction C, ray travels from C to D point. That is your translation of ray. So these 5 steps, by considering these 5 steps, we can investigate the propagation of light ray from object to image. Okay, so here A to B is your translation of ray. At point B, refraction. Again B to C, translation. At C, refraction. Again C to D, translation. Okay, with the help of these 5 steps, we can get the image information by image information of the object A dash, which is in the input plane. Okay, so how we are going to do that? Here, for that we have to consider the coordinates of different points. Now the coordinate of different points are, first, coordinate of point A. Here the coordinate of point A is your yi alpha I. This angle is your alpha I. Okay, here yi represents the height of this object. I represents the input plane or input information. Coordinate of a point B. Coordinate of point B before refraction and after refraction. Here before refraction, if I am going to consider at point B, y1 and alpha I. This is the, if this is alpha I, obviously this will be alpha I, because this dotted line and this dotted line are parallel with each other. Both are parallel to the principal axis, this one. So if this is your alpha I, obviously this will be alpha I. So before refraction, the coordinate of point B will be y1 alpha I. y1 means this height, this height. bm height is your y1 and alpha I. After refraction, the coordinate of B will be y2. y2 will be equal to y1, because the point B is the common point before and after refraction. Hence y1 height will be equal to y2 height. But after refraction, the coordinate of B will be written as y2, here alpha 1, y2 alpha 1. Okay, then we are going to go for the translation of motion from B to C. So coordinate of C, here coordinate of C before refraction, after refraction. Before refraction, here this height is considered as y3 and this angle is your alpha 2, y3 alpha 2. After refraction, this height and angle is your this one, alpha O. So after refraction, the height will be y4, which will be equal to y3 itself, y4 and alpha O. Okay, then coordinate of point D. Coordinate of point D will be alpha O and yo. Height is your yo and angle is your alpha O. So these are the coordinates of the points A, B, C, D before and after refraction. Now we are going to write the matrices for each and every point, or for each and every dynamics. First we are going to consider the translation or the step 1. Step 1 is your translation of ray from point A to B. For that we are going to consider the translational matrix, right? So the translation from point A to B, what we have to write? The information about point B, that is your y1 alpha I. Before refraction I am telling, y1 and alpha I will be equal to translational matrix operated over coordinate y1 alpha yi alpha I, or you can say when the translational matrix will be operated over the object information, we can get the point B before refraction. So here before refraction at point B, the matrix form can be written as y1 alpha I equal to translational matrix. For the first translation it is written as tm1 yi alpha I. Okay, this is itself 2 cross 2 matrix. This translational matrix is itself 2 cross 2 matrix. Already we have been discussed in our previous class. You just refer that video. Then refraction at point B. If I am going to consider refraction at point B, then what will be the coordinate? The coordinate will be y2 alpha 1. Here y2, this height y2 and alpha 1. y2 alpha 1 will be equal to refraction matrix will be operated over this one y1 alpha I, y1 alpha I. Here rm1 is represents the first refraction itself. This is itself a 2 cross 2 matrix. Already we have been discussed. Here I am going to show you. Here any translational matrix, if I am going to consider even for the convex side, this is a 2 cross 2 matrix, and you just recall translational matrix also a 2 cross 2 matrix. So only for that I written over here a 2 cross 2 matrix. Then we are going to go for our second translation. Second translation means the ray translate the ray propagates inside this optical system from B to C after refraction. So at C before refraction, what will be the system of matrix? That is your y3 and alpha 2. So y3 alpha 2, here y3 alpha 2, this is the information of point C before refraction, can be found by operating the translation matrix over previous information. So here translational matrix is nothing but your second translational matrix. So this is your tm2, mistakenly I written tm1, this is your tm2, will be operate over the previous information. Previous information is your this one alpha y2 alpha 1, y2 alpha 1. So this is your previous information operated by translation matrix 2, we can get y3 alpha 2. Then we are going to consider refraction at point C. Refraction at point C. So after refraction, what will be the coordinate? We found here y4 alpha O. y4 alpha O can be found by operating the refraction matrix on the previous result. So the previous result is your what? y3 alpha 2. So this refraction matrix, which is your 2 cross 2 matrix, is operated over previous information y3 alpha 2. So here this is also a rm2, mistakenly written. Just wait, I have to correct it. So we found after refraction the coordinate of C in matrix form, it can be written as y4 alpha O equal to rm2 y3 alpha 2. Here rm2 represents the second refraction matrix, which is itself a 2 cross 2 matrix. Then we are going to go for our last translation, that is your from C to D point. So C to D point, after translation the coordinate of D is your what? yo alpha O. yo alpha O, if I want to write in the matrix form, that means I have to apply the third translational matrix on previous information, previous result. The previous result is your y4 alpha O. So when translation 3 matrix will be operated over y4 alpha O, we can get the coordinate yo alpha O. That is your final information, or you can say image information. This is your image information, that is your d dash, or the coordinate is nothing but your YO alpha O. In matrix form, it can be written as in this format. Again, this 3 TM3 represents your third translational matrix. Again, this is your 2 cross 2 matrix also. Now consider YO alpha O, which is nothing but this one. Okay, so here instead of this matrix Y4 alpha O, we can write this one. Okay, I have to write same. So instead of Y4 alpha O, instead of Y4 alpha O, we can write this one RM2 Y3 alpha 2. Instead of Y3 alpha 2, we can write this one, right? So instead of Y3 alpha 2, we can write TM2 Y2 alpha 1, right? Instead of Y2 alpha 1, what we can write? We can write this one. So instead of Y2 alpha 1, we can write this one RM1 Y1 alpha I. Again, instead of Y1 alpha I matrix, we can write this one TM1 YI alpha I. So same thing I am going to write. Instead of Y1 alpha I, we can write TM1 alpha TM1 Y1 YI alpha I. So here you can see, if we have the information about the object or the coordinate of object, that is your yi alpha I. Again, I am telling to you that this I represents the input information. Not this I stands for input, not image. Don't be confused. Okay, so here this coordinate yi alpha I, which is represented in matrix form, if we have the information about the object, we can found the information about the image or the coordinate of image, that is your yo alpha O, yo for your output information or output coordinate, which is represented as yo and alpha O, can be evaluated by using these matrices. So here you can see all are 2 cross 2 matrices, 2 cross 2, 2 cross 2, 2 cross 2, 2 cross 2 matrices. So if I'm going to multiply all the 2 cross 2 matrices, then also we can get the again 2 cross 2 matrix. After multiplication all these 5 matrices, again finally also we can get 2 cross 2 matrix itself. Okay, this 2 cross 2 matrix is called as your system of matrix of whole dynamics. That means from object to image. Got it? Same thing I have been written clearly in our next slide. Here you can see yo alpha O is the information of your image is equal to multiplication of these 5 matrices. This one, this is itself a 2 cross 2 matrix, which is called as system of matrix of whole system, represented by Sm. When we are going to operate this Sm or these multiplication of these 5 matrices upon the input information or object, then we can found output information or image. So this is the input information that we know. If I'm going to apply this matrix, or you can say multiplication of these 5 matrices, or in short it is represented as system of matrix, we can found the output information or output coordinate, which is written in the matrix form. Okay, this Sm called as your system of matrix of this optical system, right? Now if I'm going to consider system of matrix of optical system, this is the whole system Sm. If I'm going to consider optical system, here optical system is your this thick lens. This is your thick lens. Okay, so if I'm going to consider only thick lens and its corresponding system of matrix, so what will be? It is represented as Sm, in bracket I written thick lens, or you can write instead of thick lens optical system. Will be what? Will be this one. will be this one, multiplication of these three matrices. Why? Here inside this optical system we can found one refraction at point B, one translation from B to C, again one refraction at C. Here A to B and C to D, these are the two translations happens outside of this optical system. Hence system of matrix of this optical system represented as SM in bracket thick lens is your this one, multiplication of these three matrices RM2, TM2, RM1. Okay, so this one is your system matrix of this optical system. In this is itself a 2 cross 2 matrix also, right? In general, the system of matrix, let us consider it is written as A, B, C, D. As it is a 2 cross 2 matrix, let us in general it is represented as A, B, C, D. Okay, you just remember this one. This general system of matrix will be required in our forthcoming classes. Okay, you just remember this one. Okay. Here another most important point always you have to remember, the system of matrix SM of an optical system will be acceptable if and only if the determinant of system of matrix is unit. Here we found whatever the system of matrix is a 2 cross 2 matrix. So any 2 cross 2 matrix, suppose I am going to consider 2, 3, 4, 5. We have a matrix, suppose in general arbitrarily we have a matrix. Can this matrix is called as a system matrix of a optical system? The condition, this matrix should follow the condition. That condition is that the determinant should be 1. Here if I am going to consider this arbitrary matrix, here you can see the determinant will be how much? 2 into 5 10 minus 4 into 3 your 12, here minus 2. So this matrix not to be considered as your system matrix of a optical system in geometrical optics. Suppose I am going to consider this matrix 1 0 0 1. Can it will be acceptable as a system matrix in geometrical optics? Yes, because here the determinant is your 1. Okay, you just remember this point is most important, most important. You can found very often this question as 1 mark question in your exam. What is the condition that a matrix will be acceptable as a system of matrix? The condition is that the determinant should be unity, the value will be 1, should be 1. So here one question I'm going to discuss one question. 3 matrices are given. Identify which matrix will be considered as system of matrix in a geometrical optics. Consider this A matrix. Here the determinant of A, if I am going to consider, the determinant will be how much? 3 into 4 12 minus 6 equal to 6. So this could not be acceptable as a system of matrix of optical system. Again consider B matrix. Here minus 3 minus 3 1 minus 3 minus 2 2 minus 4. Okay, this will be minus 3 plus 4 is equal to 1. Okay, so this B matrix will be considered as your system matrix of a optical system. Consider C matrix. Here minus 4 minus 6, 2 into 3 6, yes, minus 6, this is your minus 10. This could not be considered as system matrix. Here in this question the B matrix will be considered as a system matrix. So in your mathematics, suppose you found any matrix, any 2 cross 2 matrix, and its determinant is your 1, determinant will be 1. That means that matrix can be used as system of matrix in your geometrical optics. In physics, its meaning, this B matrix meaning in physics means it is a system of matrix of a optical system. Okay, so here I am going to stop this class. In our next class we are going to discuss cardinal points and cardinal planes of an optical system. Okay, look at here in your syllabus also this topic is given, cardinal points and cardinal planes. First we have to discuss in general what are the cardinal points and cardinal planes of an optical system. Then we are going to discuss in the next class we are going to discuss location of cardinal points. Okay, so location of cardinal points and planes is nothing but your application of system of matrix, what we discussed in our today class. Okay, so thank you so much for watching this video. Thank you.